Hello, everyone. I welcome you all for the data science course. Today, we are going to discuss about data science process. In the last lecture, we had a discussion on what is data science, what is big data, and what is the importance of data science, and in which what are all the fields in which the data science is demanding. So those the introduction we had a discussion in the last lecture. In this lecture, we are going to see what are the data science process. Okay, so this is the brief of data science process. First one is for any process before we start the solution to the process. First, we need to know what is the problem. What is the problem statement or what is the goal? So that is the first issue in the process. First, we have to define the problem statement. Suppose if I want to find what is the root cause of cancer, or if I want to say that this cancer is curable. So, if I want to apply data science and I want to get the model means, first I have to frame the problem statement properly, or I have to set the research goal. So that is the first point in data science process. First one is setting the research goal. Then once you set the research goal, then next one is retrieving the data. For example, we'll take for entire thing we'll take cancer. I need to find which stages of cancer is curable. Okay, so the problem statement is I need to come to an idea that stage one, two, three. So in among these, which stage is curable? For that, I have to develop a statement. So I have clearly specified what is the problem statement. Second one is retrieving the data. So I have to collect the data from my neighbors or from my friends or colleagues or from the hospitals. So I have to collect that how many of them are affected from stage one, or how many of them are reported as stage two patients, stage three. So I have to retrieve the data. So once I retrieve the data, I have to prepare the data properly. Suppose not all patients would reveal their stages. Okay, so in that case, that data will be blank, or uh, some errors may be there. So while the data is being collected, so typo error may be there, or the listening. The whatever they say it is misinterpreted. So those errors are obvious. So those errors are normal in data retrieval. So those data has to be prepared properly. Okay, then data exploration. That is, from the data, I have to get the trend, I have to get the pattern, I have to check based on the graph pattern, I have to say which one is curable. Then once I get the trend, then I have to go for a model. I can apply a machine learning model, or we have plenty of machine learning models like machine supervised model, unsupervised model, non-linear model. So in this random forest, least squares estimation. So these are the varieties. So we have to choose which one is the best. So that is called a data modeling. And once we choose, we have to apply that modeling, and we have to present that data. Okay, so this is how your data science process works. In that first process is data uh, finding the problem statement or setting the research goal. So in under this research goal, we have to say what is the proper definition of the research goal, and create a project charter. Like we have to create from which the data from 1980 to 2025, or the data from 2000 to 2025, or is it only for more than 50 years or less than 50 years as well, or is it only for blood cancer or lung cancer? So likewise, we have to create a project charter, so on which we are going to concentrate. So that is your creating project charter. Okay. So data science is mostly applied in the context of an organization, a clear research goal, the project mission and context, how you're going to perform your analysis, what resources you expect to use, proof that is an achievable project, or proof of concept, deliverables, and measure of success, a timeline. So all these we have to mention in the charter. First, you have to define a statement, and we have to locate the, whether we have to narrow down or establishing. And once you do that, we have to prepare a chart. So in the project charter, we have to mention clearly everything. How you're going to perform analysis, how long you have to take, what are the sources do you want. So those will be listed under this. Okay. So the next one is, so first we have done setting the research goal. Under this, we have to clearly define the statement and we have to create the project charter. Okay, the next one is retrieving data. So whether the data retrieval could be internal or external. So internal means data retrieval and data ownership. So let's see what it is. So data can be stored in many forms, ranging from text files to tables in a database. In a database, it is saved as a table. The objective now is acquiring all the data you need. So we don't need to look only for text files, or we don't need to look for only audio files or video files. Our main aim is we have to acquire all data, then later we can do the processing. So these are the data storages. First, database we all know. The next one is data marts, data warehouses, and data lakes. So these are the storage devices in which we can store the data. Okay, first one is data warehouse. Data warehousing is about the collection of data from varied sources. So first we have to collect the unprocessed data. Okay, and then we have we have electronic storage of massive amount of information, and it is a blend of technologies that enable the strategic use of data. Then once it enters into the warehouse, first we collect these data, and that data is converted into a processed one. So that is data warehouse. So under warehouse, so we have data mart, various data marts. Say for example, this is Amazon. So Amazon is a big data warehouse. Under that, so this part collects only the sales of electronic gadgets. This deals with only clothes. This deals with kitchen items. So likewise, we can have n number of we can have data marts, but all data mart belong to only one type, one category, whereas data warehouse is a blend of different categories. Okay, so this is data warehouse, and then from this we can say that this needs a big storage, but this all needs little storage because it is limited only for a particular category. It has various categories. So let's see the difference between data warehouse and data mart. So data warehouse is a large repository of data collected from different sources, whereas data mart is only subtype. Data warehouse is focused on all departments in an organization, whereas data mart focuses on a specific group. Suppose if you take an university, so data warehouse shows the students from medical, law, or humanities, or arts and science, or engineering, dental. So likewise, it varies. Whereas data mart specifically concentrated on engineering, or if it is engineering, means it is concentrated only on particular department. So that is the data mart. Data warehouse designing process is complicated because it involves huge data. Data warehouse takes a long time for data handling, whereas data mart takes a short time for data handling because of the less number of data for data lakes and huge data for data warehouse. Comparing data warehouse versus data mart, data warehouse size ranging from 100 GB to 1 terabyte, whereas data mart size is less than 100 GB. We know that. When we differentiate data warehouse and data mart, data warehouse implementation takes 1 month to 1 year because it involves huge, whereas data mart takes only few months to complete the process. So we can store the data in database, data warehouse, data mart, and we'll see what is data lake. So data lake is a centralized storage repository that holds a massive amount of structured and unstructured, whereas data warehouse, once the data is input into the output of the warehouse is structured, whereas data lakes is not so. So it has both structured and unstructured. So it's a collection of storage instances of various data sets in additional to the originating data sources. Data lakes are a fairly new concept, and experts have predicted that it might cause a death of data warehouse, but still, uh, preferably, most of the organizations they prefer keeping the data in the structured format in the data warehouse. So this is the difference between data warehouse and data lake. So this is your data warehouse. This is the data lake. So you can see the patterns, see the combination of different zeros and ones. This is the data. So this data, once it enters into the data warehouse, see the sorting. So we can group the colors. So these colors involve this category. So this may be electronic gadgets, or this may be clothes, or this may be some engineering students, or this may be some elder people, or this may be some cancer patients. So likewise, based on the category, it is grouped. So this is data warehouse. Whereas here, see the same data is fed over here, but once it is out of the data warehouse, so the data is structured, but here still it is unstructured only. So this is the difference, the major difference between data warehouse and data lake. So few additional points are: storing data is relatively inexpensive in data lake, but in data warehouse, it is a time consuming because it has to apply special techniques to sort. So that's why it is time consuming and it is expensive as well. And it is costly to make, even if you want to make a change, it is costly because maintenance issue is there, but it is not so because the data are not, structured. It is in semi-structured, unstructured. So there is a natural form. The data is in natural form. The schema is defined after data is stored, thus making it hydrogen. But schema is defined before data is stored. So here, before the data is stored, it should be structured, but here it's not so. Whenever it is required, then in data lake we can structure the data. So this is the difference between data lake and data warehouse. And some more data providers. So one is data.gov and open data.europa, Freebase, Data World Bank, Aid Data, open.fda.gov. So these from these we can collect our data based on the research goal. So second process also over. So first process is setting the research goal, and the second one is retrieving the data, and third one, which involves huge processes. One is first we have to clean the data, and we have to transform the data, and we have to combine the data. So data, why data cleaning is important? Because instead of nowadays we are used to mobile. So whenever we text, we won't type GOOD, good morning. We always say GM or GDMG. So like a short form we used to. So there are lots of chances for data entry. I mean error from the data entry. So instead of good, we may put GD, but it creates an error in data science. So we have to watch carefully. The errors from data entry should be avoided. Next, physically impossible value. Suppose if you're inquiring again the cancer patients. So there, if you are if you are collecting the ages, so if someone enters 120, is it highly impossible? So those physically impossible values have to be noted. So if you note that and if you clean, then that is, this is an importance. So this gives a demand for cleaning, gives the necessity for cleaning. Another one is missing values. Yes, all the patients are not ready to give their data. So those the values are considered missing. Then outliers. So definitely, suppose if you take a class and if any teacher, if they give any assignment, most of the students they don't do, but very few students they do the assignment. So the other students stop them not to show. So in that class, those students who did maybe two or three students who did the homework, they are considered as outliers. So they are not part of the group. They are away from the group. So likewise, whenever you collect the data, you have to look for outliers. So obviously we have to remove the outliers so that we get the data which is closer to the analysis. So outlay is also important, and if you have any spaces or any typos, then you have to neglect that. And errors against code book. That is, suppose if you're taking any observations of any experiment. So in that experiment, it says So the temperature has to be recorded from 0 to 200 degrees Celsius only, but you should not record more than 200. So that is called as, I mean, the code book rules, but you should not go against the code book. So this is data cleaning. Then after the data transformation, so you can combine the data or you can extrapolate. That is, from the data you can apply um, some mathematic tools to extrapolate. That is, you estimate the data, and you can derive the measures from that, or you can create dummies, or because these are all for transformation. That is, whichever way we like, reducing the number of variables. So if you want, we can go for transformation. These are the various methods. Then finally, once it is cleaned, once it is transformed, finally we have to combine everything, and we have to set some operators, or we have to create a view. So this complete process comes under data preparation. So we already discussed what is cleansing data. So it's a sub-process of the data science process that focus on removing errors. So if you have any error in the data, first thing is we have to remove the error. If the error is not removed and the process is continuing, means it is of meaningless. So first we have to remove the errors. So true and a consistent representation, that is interpretation error, inconsistencies, you have to point out. So first error is data entry error. The data collection and data entry are error prone processes because humans are only human, so they may have, or they may make typos or lose their concentration for a second and introduce an error in that. Even we can't say that machines or computers are free from errors, because if it is a failure, if machine fails or if the hardware fails, definitely we'll have error in the data. So this is one example. Actually, in the data, the value of that particular query is good. But see, so this much amount of people, they have typed good, but 15, I mean 15 people, they have typed as good. So this is error. This is error. So we have to remove this. Similarly, bad, and then instead of this spelling, they might have put BADE. So this is one example for data entry. It's impossible values and sanity check. So we have to check whether the age is less than or equal to 120 or greater than or equal to 0. Sometimes this can be narrowed also based on the research problem. So we have to consider the impossible values and remove it. So this is also one of the process of data cleaning. And I mean, once you find the error in the data, or if there is any missing data, we should know how to handle it. So one such handling mechanism is omit the value. So suppose if data is missed, so you have to omit. So it is easy to perform, but there is a chance for losing the important observation. So while you omit the values, so be careful, like is there any chance to get the data again from that person? So these check has to be done. Then set value to null, because the code, uh, it may not consider the blank value. So for that you have to replace that with a null value. So it's also easy to perform, but not every modeling technique. So certain modeling techniques, they don't prefer null values. So we have to check again. Then impute a static value such as 0 or the mean. So instead of omitting it, or instead of making it null, we can impute as a static value which don't vary, or a mean value. We can put the substitute as a mean value. It is also easy to perform. We don't lose any information, but it can lead to false estimations, because if you replace the mean with the mean value, definitely it leads to false estimations. So again, care should be taken. Then impute a value from the estimated estimation. That is, suppose if most of them uh, they take 2 hours to understand a particular concept, then we can, from that we can estimate. So this is obvious for the other persons who are staying in that room. So that kind of estimation we used to make from the other data. So it does not disturb the model, but this will not disturb the model, because the model data is taken as the estimated value, but harder to execute. Okay, so for this we have to do some data assumption. The data assumptions should um, collide with the research proposal or data collection. Then modeling the value, so it does not it does not disturb the model too much, but it can lead to too much confidence in the model. So uh, because once we finalize, so we have to model the value. So it is, I mean, it will give too much confidence, but it is harder to execute. So this is how we have to handle the missing data. And outliers. So outliers is, for example, you take this. So in this, you can see all the data are here, but here one data is where it's far away from the actual group. So in that case, we have to remove. So we have to handle this outlier as well. And then this is one example. This is a normal data. This is one example for the outlier data. See, there is a gap. So it's very hard to predict. So in that case, we have to omit. Okay, and make sure that the main information will not be lost. Then if you have any redundant white spaces, uh, for example, yeah, if there is any white space, so we have to replace with null value or mean value. And if there is any capital letter mismatches, so we can use Python to check whether all the letters are lower or all the letters are uppercase, is in uppercase. So this is one example for redundant white spaces. And then deviations from the code book. So uh, I mean, during data collection, from the data collection, they have made or once they set the research goal in the charter, uh, they give this description of the data. So that becomes a code book. So you have to follow that code book. So it should not be against the code book. For example, in the code book it says you have to I mean, capture only few number of variables. So you should obey that. And the encoding value. Suppose in some cases, or in that code book it says if there is zero, then it is considered as negative. If it is five, it is considered as very positive. So you have to follow that. So it should not be deviated from the code book. So that is very important. So next one is data transformation, because we have done data retrieval and data collection. And once we collect the data, we have to do the transformation. Then once we do the transformation, we have to combine. Okay, so the transformation we have done. So this is combining data. See some example. So here customer ID and the same customer ID, but with two different data, two different column key values, but it has to be combined so that uh, otherwise it's waste of time. It takes the storage space more. So this has to be done. So for that purpose, enriching, joining or enriching an observation from one table with information from another table. Another one is we can do appending or stacking, adding the more, I mean, adding the observations from other table also. Then one more example. So here only two IDs, here other two are there. Since it belongs to the same category, we can combine this. So this is one example for combining data. And one more thing is joining. So joining, we have I mean, various joins like inner join, outer join, and then left join, right join. So we will see this in pandas or in the upcoming classes. So joining is you use variables that represent the same object. See here, client and item, month, client and region. So here region is not here, okay? But all the others are same. So under client, we have to check both. So both are same client. And item is not there, but you have to put item here. And month also here. But region, this key value is not in this, so that has to be added. So this is one example for joining. And one more example is here in both the table, the client item month are same number of columns. And so since it is appending, so so there is a chance for repetition also. See, the data is repeated, but item defines the same, because in January these guys they bought this, and in February they bought this. So it is called as appending the data at the end. The next one is views, like how to represent the data. So these are the data which says about January sales, everything. We can put everything as yearly sales. So this is one example. Then we have to enrich the data. Enrich the data is for presentable only. So here we used to collect the data under sport and whether the product is sport one or sport two, and sales also, and then sales in dollars, or this is one sales, this is another sales. Then we can check the sales growth also. So the extra data will be, I mean, um, extra information will be added to this. So that is called as enriching. So data enrichment can also be done by adding calculated information to the table, such as total number of sales. So this could be added along with the data. Once we get the data, we can calculate this so that we can enrich the data with the good presentation. Then next one is transforming the data. So we have to transform, for example, here this is the value, x values are given. So you're going to transform to y because it's very hard to plot. So for plotting, this is easier. So in that case, we have to take log of the value. So x one is suppose, yeah. One more thing is, if x value is huge, see, if you take 10, if you take log value, it is one only. So likewise, if you have like 300 or 1000, so in that case, your log value you take the logarithm of that value, it will be reduced. So it's easier for us to plot. So in that case, you have to apply logarithm to transform the data because it is required. So that is why x data is there, and then logarithm of that value is taken so that you can easily plot between y and the log x. So this is one plot. So this is called as transforming data. Then reducing the number of variables. So don't add new information to the model. Model difficult to handle. So because of too many variables, if you have more variables, so we cannot add new information. Then it is very difficult to handle. And then certain techniques may not perform well because if you are loading the system with too many variables. So data scientists use special methods to reduce the number of variables, but they'll retain the maximum amount of data because the data should not be lost. So next, turning variables into a dummy. So in this table, in 2015, you have, I mean, the female say female made sales as 10. Okay, but in the same year, male, so we can combine that mail data here. For example, take the first data 2015, and then sales is 10. Okay, and then that sales is only made by female but not by male. So you have to put zero, zero for that. Okay, because you're transferring the data into dummies, because we can fix that if it is 10 or more than 10, it is treated as 1. If it is less than 10, it is treated as 0. Then we'll see the next one. In 2016, so 11 made, so which means under female it is 1, and under male it is 0. Okay, so here in this case, so we can convert the dummies into ones or zeros based on the numbers, or based on the male category or female category. So it is dependent on the requirement. For example, the dummy variables can take the values true or false. They are used to indicate the absence of the categorical effect that may explain the observation. So in this case, so for example, if we take 2016, we have female 14 and male 13. So here 2017, so one is 13, so 13 is made by male. So for male, we have to put 1. And then 14 is made by female. So for female, we have to put 1. For the other categories, it is 0. Then if you take 2016, we have 11, 12 data. So 2016, we have 11 and 12 data. And then 11 is for female. So for 11, female 1, and 12 is male. So for 12, it is 1 for this. And 2015, 10 and 8. So we have 10 and 8 data. So if it is 10 means that is male. If it is 8, that is made by female, male, sorry. 10 is from female and 8 is from male. So likewise, we can, in order to understand, we can convert that variables into dummies based on the necessity or based on that scenario. So we have done like how to set the research goal, how to retrieve the data, how to prepare the data. And the next one is data exploration. So we can make this using simple graphs, combined graphs, link and brush, and the non-graphical techniques. We'll discuss one by one. For example, usually visualization improves the understanding. For example, let's take Sankey. So this model is called as Sankey. So here from the picture one can understand that 32. The jobs applied to 32. So 32 students applied for the job. So for that, or a person, he had applied jobs to 32 companies, so he got replies from 15, and then five companies rejected him, and then there is no reply from these 12 companies. So among this 15, he had interviews for nine companies, and the task requested four, and offer received two, accepted one. So likewise, so by seeing the representation, by seeing the visual treatment, one can understand easily what happened. So how many jobs he applied? At the end, he had accepted only one and he had rejected one. And then he had got the offer for two companies, and three were rejected. So this idea can be understood based on the graph. The different types of graphs. So this graph is Sankey graph. So this is one network graph. Then we all know about simple graph and histogram. So this is one example for bar chart. So we know that under this year, so this much sales done, or this much students or graduates. So likewise, one can understand. And this is one line chart. And then this is the so in overlaying, if you want to understand the relationship between this data with this data, means we can check that relationship alone, and then the same with other data. For example, let's take this as A. Okay, so A with B and A with C. So the relationship can be studied, and then same A with D and A with B. So these are all, two is A, we can say this is B, C, D, E. So in order to understand the relationship between A with B, A with C, A with D, A with A can be studied uh, by considering the overlaying process. Next one is brushing and linking. So brushing and linking means first we have to choose the data. So for example, this data is chosen means, so this data has to be, it is used as a brush here. So if you want to see, this is one data, this is another data. In that data, you have to link. So you have to see these two data can be seen over here. So, and then this is another category, but this data which is already chosen as a standard one, so that has to be linked with the other data. So this is called as brushing and linking. This is also used to give the analysis. So analysis of this particular data with respect to the other category, with respect to other category. So first we have to choose it in a rectangular column, and we have to brush it. Brush it means you have to brush the data with the other categories as well, and we have to link it. So through this way, one can understand, or this helps for exploring the data. And next topic is model. So we have done, we understood what is setting the research goal, retrieving data, data preparation, exploration, modeling. So now we have come to the last section, which is modeling. So first we have to choose the model and the variable for that, and we have to execute the model. Then we have to do the model diagnosis and model comparison. Then finally we have to go for presentation and automation. So data modeling, it consists of main steps. So first you have to select the modeling technique and how many variables are required for a model. For example, if you take y equal to mx plus c. So for example, so if you take y equal to this is one model. Okay, y equal to mx plus c. So y equal to mx plus c. So after at the end of the modeling, we should be able to know what is m and what is c. So if you choose the model, suppose if we choose this model, so in that the number of variables are m and c has to be modeled, and then for that we need y variable and x varying variables. So likewise, first you have to select the modeling technique and the variables to enter in the model, and you have to execute the model, then you have to diagnose it, and you have to compare the model. So these are the steps. So for model and variable selection, must the model be moved to a production environment? So once you do the model, so it should be applicable for the production environment as well. And we have to check whether it is easy to implement in that production environment. But if it is not easier to implement, means then we should not choose that model. So once you, while you are in the process of selection, model selection, you have to check whether it is applicable for the environment you looking for, or whether it is easier to implement that particular model, and how difficult it is to maintain the model, or if the model is not used for a long time, will it be still relevant, or how long is the expiry, and does the model need to be easy to explain? So we need some extra effort, or we need to buy some resource, we need to recruit some resource persons to explain, or how easier the model is. So these things we should concentrate on in the modeling part. So we'll see one example in using Python. How do we do the model? So this is one example. So here we are going to use statistic models, because all the this model in this ordinary least squares is used. So that is in statistic model. Then this is application programming interface. So uh, we are going to use the data from API, and then that data is in stat model, and we are going to name it as SM. Okay, then NumPy we know, and we need the plot as well. So we are going to use the pyplot function from matplot library. So first we have to generate 1000 data. Okay, 1000 data means we're from 0 to 1 randomly we have to select 1000 data. That 1000 data should be in 500 rows and 2 columns. Okay, so 500 to 1000. So 500 rows and 2 columns. So randomly it will generate the values are from between 0 to 1. Okay, so first we have to generate the data, because we are not, the data is not collected anywhere. So it is generated. Okay, then in that we have to add some noise, because it is between 0 and 1, so the data is very less, so we need to add some noise. For example, point 4 means the first data, so this is the first column, let's say A, this is the second column. So each A data, each A data in all the rows, that has to be multiplied by point 4. The other data has to be multiplied by point 6, and then both should be added. So in that way, we are adding noise to all the data, and we can print this target also to see how it is, how the noise is added. Okay, so in the first step, we have generated the data randomly, and we have added some noise. Okay, so next we are going to fit two models, because there are two columns. First, we'll take the first column. So in that, what we do is, first we have to add some constant, because the equation is y equal to mx plus c. We have to add some constant, since we are not aware of, because we are going to find the constant value. But before we find, first we have to replace that value by 1. So in this, so this represents all 500 rows. This represents first column. So for the first column, all the rows you have to replace by constant. That constant is 1. Adding 1 as a constant for the first column. Okay. So once we do that, then for the because this becomes so this x1 is with ones, let's say, so this is ones and some data which is added with noise. So this data is added with noise. So this entire setup is called as x1. So that has to be modeled. So we are going to use OLS model. That OLS model is in statistic model. Okay, so ordinary least squares regression model we are going to apply. Once we do that, then we can fit the model. First we have to apply the algorithm. From that we have to fit the model. So once we get the model, we have to predict the value also. So this entire thing will give you the value uh, y equal to, for example, this m is, for example, I'm saying point 0.4. So this is from the model, 0.4x plus 0.4x plus 0.2. This is for example. So from the model, we found that C is 0.2. ms.4. So this is how we can generate the model using Python. The same concept is applied for the second column. For the second column, you have to replace by constant. Then you have to apply ordinary least squares, then get the model, then you have to predict the value. So once you fix the model, then model in the sense y equal to mx plus c or y equal to 0.4 x plus zero point 0.2. From that, you have to predict. So with this, you have to find what is x2. So actually, from see we have predicted as y equal to zero point 0.4 x plus zero point 0.2. Okay, so what we do is, so in the place of x you have to replace by x2 value, and we have to check whether you are getting y2. So this is how we can check whether the model is correct or not. Okay, so the steps is, first you have to generate, and you have to add some noise. Then before finding the model, we have to add 1 to the in the column. Then you have to call for the modeling name, which is ordinary least squares. Then you have to fit the model. Once we fit the model, with that model, we have to give different values to predict the x1. And we can check whether this x1 and then this x1 are they same. Okay. So and then once we do that, then we have to plot it because data visualization is important. So here we are going to plot figure, and then the size is 12 inches in width and 6 inches as a height. So we have created a space for the figure. In that we have taken the first subplot. Subplot is 1, 2, 1 means this is the first row. First row is divided into two compartments. So this is first row. In this divided into two compartments. In that the first compartment is I'm going to plot the x1. Okay, second compartment is x2. So here 1, 2. So one row is split into two columns. In that first column is for the x1 and second column for x2. Then we have to plot. You have to use the scatter plot. So first you are using the first column. Here second column data. So that has to be scattered. The color of the scatter is blue. Then the label data points. Similarly here. And the next one is we have to apply the predictors also, because this is the actual value. This is the predictor value. From this we can say whether the model is good or bad. Similarly here, so we have to show the difference, blue and red and green and red. Okay, because red is the predictor and the blue is the from the model. Okay, so we have to label it. Let's see the picture. See here. So target versus predictor for x1, target versus predictor for this. So these are the data points. These are the fit line. So instead of taking all these points, we can, we modeled all the points as this line. Here also, we modeled all the points as this line. Okay. So this is how we have to model. Okay. So this is also related to that. So here, this is the model we got it, y equal to mx plus c. So this is the m value. This is obtained from the model. This is sorry, it's not mx plus c, but it is m1 x1 plus m2 x2. And okay, suppose if we add three values, means it's m3 x3, so likewise. So this is the model. We can say complete model. With this model, we can apply x1 and x2, and we can find out the y value. Then we can compare the predicted value with the actual value. So that's all for today. So today's class, we have just seen the introduction to data science process. Thanks for watching.